Alright, in this video we are going to learn how to use the equation v equals f times lambda. Now, one thing you may have noticed is that I did not call that upside down giraffe looking thing, or whatever you want to call it. I did not call it squiggly y or upside down y. I just called it lambda. So that symbol, lambda, is actually a Greek symbol, and it will represent the wavelength. And the wavelength tells us how big a wave is in meters usually, which we write as m. So for any wave, for example, if we have, a wave like this, right? The distance from this point to this point is the length. So this little distance that I'm drawing here. In other words, this is how far the wave has traveled as it crossed through. The other thing in our equation is v, the speed of the wave. The speed of a wave. This just tells us how fast it's going. So how fast it travels, or how fast it propagates. And we usually measure it in meters per second. Okay. And the last thing is f, the frequency. Now the frequency you may have already learned about before, but the frequency is measured in hertz, which we write as Hc, and it basically tells you how often or how often the wave occurs, how many waves you can fit into 1 second, how many waves occur in 1 second of time. So if, for example, you have, say you're at the lake and you're watching the water just kind of crash against the shore, count how many waves you see in 10 seconds and then divide it by 10, and that would give you how many waves happen in 1 second. That would give you the frequency of the waves. Now, for ocean waves and stuff, that's a pretty low number. It's usually 1, 2, maybe 3 or 5. But for sound, they can get into the hundreds, and for light, into the thousands and millions even. So this number can get really big the smaller and faster the wave travels. So those are the 3 components that make up our equation v equals f times lambda. So we should be ready to go to do an example, a mathematical example. So let's go ahead and do that. So I'm going to adjust this here. We're going to move there. I have this example ready, and it says, after a bomb explodes, a wave that is 2 meters long is detected at a frequency of 160 hertz. What is the speed? At what speed is it traveling through the air? So I'm going to write on this a little bit. After a bomb explodes, a wave that is 2 meters long is detected with a frequency of 160 hertz. At what speed? So is it traveling through the air? So let's write down what we know. 2 meters long. So I just kind of underlined frequency of 160 hertz. And what speed? That's our question. So here's the information that this problem gave us. I always like to do this where I underline things that are important. Numbers, keywords, stuff like that. So 2 meters long, that's length. Well, then that must be the wavelength. So that must mean that lambda is 2 meters, since we said earlier that lambda can be measured in meters. The second thing that we saw, the frequency of 160 hertz, well, that tells us the frequency is 160 hertz. Excellent. That was pretty straightforward. And what do they want to know? They want to know speed. So what is speed? And since these are standard units, I'm going to go ahead and assume it's going to be in meters per second. So how would we do this? We would plug in our numbers for our formula. Now that we have kind of identified everything that we were given, let's take our formula, right? Let's take our formula V equals F times lambda, and let's plug in our numbers here. So what do we know? We know that the F is 160 hertz. So 160 times lambda is 2. Okay, that equals V. We don't know what that is yet. V equals 2 times 160. Well, isn't that just 320? And what units did we say we were going to use? Standard units, meters per second. So we just found our speed. Remember that in physics, formulae like V equals F times lambda, they aren't necessarily math formulas. This isn't a math formula. What this actually means is it's actually a shorthand way of writing a long sentence. And the long sentence says, a wave's speed is determined by how often it goes by, or by its frequency, and by its overall length. So if you read through this little sentence here, you can kind of pick out everything that we were talking about. A wave's speed, V, is determined, so is equal to, that's where we get that determined, its frequency, and its overall wavelength there. So you can kind of see here that the equation is just a simple way of writing down something we already know. Okay? Now, just to recap what we did here. We used our equation and what we know, what velocity, frequency, and wavelength are. We read the problem through, and then we picked out key pieces of information, and we used them to kind of figure out what goes where, plug them into our equation, and then we keep our answers in a box to keep them neat and simple. I hope that makes sense, and hopefully that clears up how to do these math ones. But just to be clear, and just to make sure that we have a good understanding, I want you to work on some problems here. And you're going to work on these for a little bit. Make sure you write them down. Try them on your own before you get help from a friend or from a teacher. It's always important to try things out on your own first, because there's no better way of learning than by doing. So give these a shot, and we'll see you next time.